Hey, welcome back to 5th grade virtual math. All right, so currently we've been discussing OA 2-3, and some of the stuff we've already went over is generating two numerical patterns using two given rules. So we took our rules that we were given and we created a T-chart with patterns on it. And then we also realized that there are corresponding terms in the two patterns that are right next to each other. And we understand that those corresponding terms create ordered pairs. So our focus for this time is to identify apparent relationships between corresponding terms. So we're going to take those two corresponding terms that are next to each other in our T-charts, and we're going to find out how they're related. And we do that by looking mathematically at their relationship. So going from our first pattern to our second pattern, how did we get there? Or we can go the other way. How did the second pattern become the first pattern? So we're going to use our corresponding terms and find mathematical relationships. That could be, I got from pattern A to pattern B by multiplying by 5. It could be a subtraction, addition, or a division problem, how you get from one pattern to another. So our focus today is going to be able to identify these relationships mathematically between those two corresponding terms. So our first example question is create two patterns starting with 0 using the rules below. You see, we have these two rules right here. In a sentence, describe the relationship between the corresponding terms of the two patterns. So the first thing we need to do here is actually create our two patterns. And if you recall, the best way to do that is using a T-chart. So I'm going to go ahead and create a T-chart right here with A and B as our two patterns. And just make sure you read carefully. Up here in the directions it says create two patterns starting with 0. So I need to make sure these two patterns start with 0. And now I'm going to follow the rules. For rule A, we add 3. So I'm going to go 3, 6, 9, and 12. And remember, I want at least 5 numbers to be safe. Rule B says add 12. So I'm going to add 12, 12, 24, 36, 48. So I've created my two patterns. Now, just recall that the numbers right across from each other are our corresponding terms. And that's an important thing to remember. So next part, in a sentence, describe the relationship between the corresponding terms of the two patterns. And again, that word corresponding terms is here. We need a mathematical relationship between the corresponding terms. So what I'm going to do is I'm going to look at the numbers right across from each other as we go down. And finding this relationship is how did I get from point A, or pattern A, to pattern B? And it has to work for every single corresponding term. We can also look at it as how did I get from pattern B to pattern A? And again, it has to work for every single corresponding term. So the first thing I notice here is I look at all these A's. How did I get to these B's? And the first thing I notice is that every single one of these have been multiplied by 4. So to get B, so I can say I get B, these right here, by multiplying I'm just going to write A by 4. So I get B over here by multiplying all of these A's by 4. So 0 times 4 is 0, 3 times 4 is 12, 6 times 4 is 24, and so on. Now the next thing you need to realize is every single mathematical relationship has two relationships. So I got B, but we can also say, how do I get A? So I get A. So how would I get A? So that means I'm going to look at B, and how would I get to A? So if I look, I'm going in the inverse direction. So I get A by dividing B by 4. So these are two relationships that we identified based on corresponding terms. In every single set of patterns we're going to go through, we'll have two relationships. So I'm going to go through this again. We created two patterns starting with 0 using the rules below. And in sentences, we describe the relationship between the two patterns. We get pattern B by multiplying A by 4, and we get pattern A by dividing B by 4. Our second example is very similar. This one states, identify the two relationships between pattern A and pattern B. So again, just like the previous example, we're going to have two relationships. How did I get from A to B? And how did I get from B to A? And we're going to be looking at these corresponding terms that are right next to each other and thinking about their mathematical relationship. So also, we're going to use what we identify, the relationships, and we're going to create equations that show these relationships. And they're very, very similar. So let's start with, how do I get from pattern A to pattern B? Well, if I notice every single time, I recognize that every single number in A, you have to multiply by 3 to get B. 4 times 3, 5 times 3, 6 times 3, and so on. So in order to get pattern B, we're going to multiply our A's by 3. Now, how do we write that in an equation? Because that's what we want. So first of all, I'm trying to get B. So what does B equal? Okay, so how did I get B? B is going to equal our A times 3. So that is going to be A times 3. Okay, so I get pattern B by multiplying A times 3. Now this can be written in so many different ways. Another way you may see this written is B equals 3A. These all both mean the same thing, and that is one relationship. I just wanted to show you that. Now, another relationship is going from, how did I get from B to get A? And since we're trying to get A, I'm going to write A equals. Now, how did we get A? And it has to work for every single corresponding term. If I notice, we're doing the inverse now, so it should be the inverse of this. I can take my B and I can divide it by 3. So I get A by taking B and dividing by 3. Okay? Now, so our two relationships that are equations would be, we get B by multiplying A times 3, or we get A by taking B and dividing it by 3. Now, to extend this problem a little bit further, the main answers we're looking for is 1 and 2, the ones I squared off in a box. Now, and I have separate sample answers here. So this one could also mean B equals 3A, which means the same thing. Now, something you may also recognize is we could write this in a different way. This could also look like A equals 1/3 of B, which is the same thing as B divided by 3. So keep that in mind. But the main equations that you can write down and we're looking for is the ones that I have boxed off. Just know that you may see it written as this way as well. So our third and final question is, identify the two relationships between sequence F and sequence G. Create two different equations that show this relationship. And here is sequence F, just like a pattern. And here is sequence G, and they're the same thing as patterns. So, and we're going to be looking at these corresponding terms to find the relationship. And we're going to use that relationship to create two different equations. The first equation is going to be, how do I get from F to G? And the second equation is how I get from G to F. So, looking at these two patterns, I'm going to start with, how do I get G? Okay. And the second one is, how am I going to get F? I'm going to go ahead and write that so you know all we're doing is, how do I get G and how do I get F? So how do I get G? That means I'm going to look at F. how did I get from F to G? And it must work every time. Now, I'm looking at 2 to get to 11. There's nothing I can multiply 2 by to get to 11. There's 7, I don't know if I can multiply or divide anything, but please realize that there are 4 operations. You have add, subtract, multiply, and divide. So we need to look at all 4 of those to find our relationship. So I'm going to look. It's getting bigger, so I'm going to try addition. If I do 2 plus 9, I get 11. Will that work every single time? Well, 7 plus 9 is 16. 12 plus 9 is 21. So it looks like if I add 9 every single time, I'm going to get my G. So how do I write this as an equation? Well, in order to get G, I take my F and I add 9. So very simple equation there. I get G by taking my F and adding 9. So G equals F plus 9. Now let's go in the inverse direction. How am I going to get this F right here? So I have to look at my G and their corresponding terms. And since we're doing the inverse, the answer should be the inverse. So if I take my G and subtract by 9, I should get my F. So F equals G minus 9. Okay? So first of all, we analyzed our 2 patterns and our corresponding terms within those patterns, and we identified the relationships. So to get to G, I noticed I had to take all of my F's and add 9. And so my equation was G equals F plus 9. To go the inverse direction, I looked at all my G's, and how did I get to F? And I noticed I have to subtract 9. So to get F, I take G and subtract 9.